Hello everyone, it's November the 10th. Alright, let's do this. Prime subtraction operation. Zero-indexed integer array, nums of length n. You can perform the following operation as many times as you want. Pick an index I that you haven't picked before. And pick a prime p strictly less than nums I, then subtract p from nums I. Return true if you can make nums a strictly increasing array using the above operation, and false otherwise. Okay, so I have this. You can perform the following operation as many number times as possible. Pick an I that you haven't picked before, so each one can only be picked once. And pick a prime p strictly less than nums I. So I need a prime list of 1 to 1000. All right, so I think I don't want to use Java anymore. Let's come back to Python. And I need to get C++ set up, but I still haven't. Pick I, have I used before, and then pick a prime p strictly less than nums I. All right, let's keep Java until we get C++ set up. And pick a prime p strictly less than nums I, then subtract p from nums I. So nums I minus p. Return true if you can make nums a strictly increasing array. Okay, so if you go from, so you want the front to be as small as possible, right? So we basically need to find a prime number, the largest prime number that's smaller or equal to this. Okay, and then you find, because this one has to be larger than this, so you find the largest. Well, actually no, because if you find this, you know what this number is, right? Like this case, p is 3, so this becomes 1, right? So for here, you can say 9 minus 1 is going to be 8. So what you want to find is the 1 largest. So yeah, so if I have an A, B, C, right? And I do A minus P, is going to be what this value is. And then B, if I have a PB, right? If B minus PB is smaller than A minus PA, then that's not going to be good. So we want to find basically a PB that's even smaller. Right? So we need to reduce B such that the largest we can find will always be, yeah, so we basically, instead of using B, I'll use B minus A minus PA. So we reduce B first to be equal to the previous. Then we find the largest that's smaller than this, then it will always work. Right, and will always work. So which means when you do B minus PB, because you already reduced it, and then which means the PB will be smaller, so it will be slightly bigger. Okay, so it's just a binary search, but we do need oh, what is this? Oh, Veterans Day. Tomorrow's Veterans Day. Alright, anyway, so what we need is a prime number from 1 to 1000. Holy crap, it's gonna be a lot. It's actually not that a lot. It's not that much. Okay, we can handle this. We can handle this. You can use a sieve for this, but I don't feel like doing it. So primes. So we basically just gonna copy this whole thing in. I'm pretty sure that's not the intention. It probably will want you to use the sieve, the sieve, the Eratosthenes sieve, to produce all the prime numbers, but come on. We are trying to do this problem as simple and as fast as we can. I think this is much faster than. I wonder if I can do a copy both? No, I can't. Nah, this is good enough. This is absolutely good enough. See? Because if you write a sieve, you might make mistakes and stuff. But this, yeah, there you go. We have the prime. And yep. So int pre is gonna be 0. For int n nums, right? And we'll say index shall equal to, oh, binary search primes n minus 3. Okay. I forgot again. What's the rule of Java binary search? Arrays dot binary search. That looks old, but this is a very straightforward function, so I think we can use it. Otherwise, we do this minus insertion point minus, so just +1 negative, right? +1 negative. So if index is smaller than 0, yes. So if index is larger or equal to 0, we use it. If index is smaller than 0, index will be but what if okay, I think it should be considered differently. I think it should be considered differently. I think if index is larger or equal to 0, that means we find it, right? And if we find it, it's perfect. Then 3 equal to 0. Else, then this is what we need to consider. We will first index shall equal to a minus index plus 1. Right, this is the insertion point. Now, if its insertion point is 0, right, that means there's nothing is smaller. That's why you return false, right? Because you need something smaller to produce a bigger value, right? So we say if index is equal to 0, well, return false. Otherwise, you find the insertion point, so we can do index minus 1. So we say pre shall equal to n minus pre, right, minus nums, non-nums primes index minus 1. Or we can say, yeah, that's that. And then at the end, we shall return true. try this. The last one. 5. So first one we find 5. So it'll be 0. Ooh, strictly increasing. Oh, I just realized something. Yeah, because if you can find it, so you need to check pre. If pre is zero, then current should not be 0. Because if the pre is 0, current is 0, then it will be 0, 0, then that's not increasing. But as long as pre is not 0, yeah, if the previous is not 0, then the current, oh, if the current is 0, then it will be the same. Okay, it's not right. But anyway, 5 will find 5, so it'll be 0. 8 will find 7, that'll be 1. And then 3 will find 3, that'll be 3, that'll, well, minus 1 will be 2, 2 will be 0. So yeah, we cannot do 0. We cannot do 0. Right? So if that will become a 0, so that this value we can reduce to 0, then we shall check the previous one. If the previous is also 0, no, whenever it's 0, it's not going to work. Because if it's a 0, that means you already minus the previous value, right? And if it's 0, that means your value will be the same as the previous value. And that is not good, right? That is not good. So basically, if you find it, you have to reduce it, right? Unless it's the first time, right? Unless it's the first time. And how do I distinguish this? So we can set pre as some different number, right? We can say pre is negative. If pre is negative, then you can set pre equal to 0. If pre is not negative, and then you get a 0, then that's no good. So you need to keep looking, right? Keep looking for the previous one. Okay, so let's set this -1 if index value 1. Okay, so if pre is smaller than 0, then you just set pre to 0. Done. Alright. Else, if pre is larger than 0, then you cannot be 0. Right? You cannot be 0. So we're going to say if index because I need to use the previous one. So if index is equal to 0, then we shall return false. Otherwise, then we can say pre equal to n minus pre minus primes index minus 1. We use that. Okay, let's try this one. Looking good. And we're going to submit it first, and then we'll think about how to not. And I think we can optimize this. For each num, n in nums, find the largest prime that is smaller than it. Right? And then we can get a delta. And for the next n, we find the largest prime that is smaller than n minus delta. Now, if the complication is when there is a prime equal to n minus delta, right? In this case, if n is the first value, it's fine. Otherwise, we need to pick another prime that is slightly smaller. Okay, so here you can see that we are doing the same operation, right? We're doing the same operation. So basically, what we're saying is, if it's larger than 0, and if this is smaller than 0, we do this, right? Otherwise, okay, so we can do this. If index is larger equal to 0 and pre is smaller than 0, then we set pre equal to 0. Okay. Otherwise, else if index is smaller than 0, then we do index equal to minus index plus 1. Okay. Well, we need to continue this. Right. And then here we say if this, we update this, right? Then something like this. If it's smaller than 0, we update index, and then we will say if index equal to 0, which means there's nothing to get, then we do this, and otherwise we'll set the new pre. Okay, don't call it pre. Yeah, I just realized this is not a good way. Call it delta. Yeah, we're gonna call it delta. We'll try it again. Looks good. We'll submit it. I got it wrong. Shoot. (998), we got 997. And 2. Wait, hold a second. It can be negative, right? No. A prime strictly less than subtract p from. Then true if we can find. 998. We pick 997, this becomes 1. How'd you make this one 2? can perform it 0 times, right? As many times as you want. Oh. So you don't have to. Oh my god, I didn't consider that. You can also choose not to reduce. Which means if you cannot reduce, I see. So basically here, if it's equal to 0, then the delta is just after you reduce it. What's the one, right? Okay, so basically if it's equal to 0, all right, and equal to 0 means we cannot reduce, but if the current value is larger than the previous, so we can say if index equal to 0 and n is larger than pre, right? It's larger than the previous, then we say it's not pre, larger than the delta. Say delta equals to n. Continue. So this is just do not perform the subtraction. Use n directly. Okay. Else, actually no. No. We'll have to do it inside. If this right, if this n is larger than delta, we do this. Say else, return false. Actually, no else, because I directly go continue. Right? So if index equal to 0, there's nothing to pick. If n is larger than, then we delta equal to that, and then we continue. But if n is smaller, then we return false. Otherwise, we do this. Okay, so hopefully this one can fix this issue. Completely didn't realize. Oh, shoot. Huh? If we equal to 0. So we have the previous delta, right? And then we are trying to see if n minus delta, if we can find something. Okay, n minus delta, and try to find. And we cannot find anything, right? We cannot find anything. Then delta is the previous value, right? So the current value, I say n minus delta, we try to find, and we cannot find anything, right? we cannot find anything because, yeah, nothing is, so I am smallest, right? I am smallest. So if I am smallest, then in that scenario, I just use n, because if I minus this is nothing smaller, which means if I minus any of the others, I'll be actually smaller, right? So yeah, then I will maintain, so no delta is just gonna be the new value, right? The new value is just n by itself. Now n is always larger than delta. And not necessarily. Here 5, right? I'll do 5, so it becomes 0. So delta is 0. Next is 8. 8 minus 0 is 8. And A will find 7. Right, we'll find 7. And that will become 1. Delta is 1, right? Delta is 1. And the last one is 3. So 3 minus 1 is 2. And 2 we find is 0. Okay, is 0. N is 2. 2 is larger than. Huh? And why this one is false? I can choose not to do the operation. And then you have to use the operation. Then that's the previous one. If you have to use the operation, then how are you going to do this? What the hell? Oh, what did I got it wrong? Oh, first of all, I already said a p has to be strictly less than num xi. Oh, so it can't even equal to 0. Oh, I cannot even equal to. Oh my god, that was, I did not read that. Did not read that. Okay, then we don't have this scenario. So delta start can be 0. And then n minus delta, yeah. And if this is larger or equal to 0, does not matter. So I don't even have to consider this. We strictly consider if delta is smaller than 0. Right? If delta is smaller than 0, I'll adjust it. And then, yeah, but this still is not right. Now everybody is true. Now everybody is true. What the hell? And how? Yeah, because the last one is true is because I simply don't do the operation. And this is true because I don't do the operation. Oh, that's not true. Because I start as 5. I cannot take 5, right? I have to take 3. So the first will be 2. And then 8 minus 2 is 6. 6, I take 5. I cannot take 5. Wait, I can take 5. That's 6, I can take 5, so it'll be... Oh, I shouldn't minus delta. There we go. We should now minus delta. Okay, try this one. There you go. Yeah, I got a little bit confused earlier, but yeah, delta of the next area from the large that is smaller than this. Yeah, there is no such complication. We have a different complication actually. The complication is when there is no prime that is smaller than n minus delta. In this case, we can choose not to perform any operation, and if the current n is larger than delta. Yep. That's about it. Okay, and check the previous one. If n is smaller or equal to 3, that is true. If n minus 3 is smaller or equal to 2, we just use it. Either 1, if you're 1 bigger or if you're 2 bigger. Why? Because if you're 2 bigger, because the 2 is at least 2, right? At least 2. Which means if you are 1 bigger than it, or if you're 2 bigger than it, because if it's 2 bigger than it, then the largest you can find will either be this, because the goal is to find something such that it can be, if it's already only 1 bigger, yeah, there's no need to reduce it. Yeah, because if you, because if you only have 1, right? If you have 1 bigger than it, there's no way to make it even better, right? If it's two bigger than it, then the best is to reduce 1, but you don't have to reduce 1, so and if you reduce 2, it will be the same, so you cannot do that. Yeah, but 2 bigger than it also, but 3 bigger than it, you can. 3 bigger than it, you can reduce 2 to become only 1 bigger. Yeah, that is actually true. Otherwise, you do this, and you try it. I have a slightly different idea. Here, I first get it, and this is just boilerplate. And then I check, right? I check this. If it's equal to 0, which means this number is smaller. Now we just say, oh, we do not perform, right? We do not perform. Otherwise, we do it. It works. Two pointers. Yeah, as a difference. If it's true. I don't know about this. I'll use my method. Alright. Took us some effort, but we got it eventually. Alright, that'll be it for today. I'll see you guys tomorrow. Adios.